Hello everyone, welcome to Apna Guruji, and in this video we are going to discuss about force and pressure. So in this video we are going to discuss the complete detail of the chapter force and pressure, that is the third chapter of class ICSE 8, and welcome to the channel. So I hope you will get understand full concept of this chapter. So the chapter is force and pressure. So first we have to identify that what is force. So in simple language you can say that force is a push or pull. So whenever you are opening a bottle, you are lifting your mobile phone, you are writing, so every case you are applying force. So force is you can divide that is on push or pull, so that can we can explain that force. And there is example when a table can be moved from one place to another by either pushing or pulling it. So either you can pull the object or you can push the object. So when we have to move the table, you have to pull or push. So whatever we are doing, that is we are applying the force. Have you wondered how the shape of the bottle changes when squeezed, or how the direction of moving ball change by kicking in different ways? So that is only depends upon the force. All the above activities can be associated with pulling or pushing. So whenever we are kicking a ball, that is we are applying force, that is pushing force, and sometimes we are uh, pulling, and this is your pulling and this is your pushing. So force can be either pull or either push. So this pull or push is known as force. In simple way you can define that force is or pull or push. Otherwise, if you give the detailed information about force, that is apart from push or pull, force is any action that has a tendency to change the position, shape and size so of the object. So you might be observed the at the time of roti making process. So when we are making the dough, we use force and the shape is getting changes. And when you ride a bicycle, when you apply brake, its position gets changes, and the size also gets changes in some cases. So applying by force, we can change the position, shape or size of an object. So whenever you ask that what is force, you can simply state as force is a pull or push, or you can say that force is any action that has tendency to make changes position, shape or size of an object. So here we have examples, descriptions and push or pull. So as like hitting a cricket ball with bat. So you may think that what is it? This is a push. And opening a door. So we can open a door by pulling or pushing. Plucking a flower, that we pluck the flower from the tree, that we pull. And here are some examples. You have to identify that what are they. Like flying a kite, it is a push or pull. Moving a wheel, borrow, it is a push or pull. Hitting a tennis ball with a racket, pull or push. You can answer in the comment section. Taking a carrot out of the ground, please answer in the comment section. Playing on a swing, picking up a shopping bag, squeezing a toothpaste tube. So whatever the answer, you can just comment down in the comment section. I will check it out. There are interaction of forces. First, you know that force may be defined as in two types, that is one is contact force, another is your non-contact force. So in contact force is that whenever two body contact each other and experience the force, that is the contact force, and in some cases without contact also we can experience the force, that is non-contact force. But you need to know about the unit of force, because without knowing the unit, how can you measure the amount of force you are applied? Like do you require equal amount of force to lift your physics book and bucket of full water? No, right? Because a book is easier to lift, or bucket full of water is heavier to lift. So in this case you are applying force in both the case, but the amount of force you are applying is not equal. So how will you measure that how much amount of force you are applying? So the SI unit, international system of unit of force, is Newton, which is denoted by N. And you must be heard of the term kilogram force, that is kgf. In your some questions there will be not written that the amount of force applied is 10 newton or 15 newton. Sometimes it is written as in 10 kgf or 15 kgf. So it is kgf, not mean by the movie. Okay, it is the commonly used to unit of force, that is defined as the force that is required to lift one mass of kg, lift a mass of 1 kg vertically upward. So when you are lifting any object vertically upward, suppose it is 1 kg, then the amount of force required to vertically lift 1 kg of mass, that is known as your 1 kgf. Or simply you can multiply mass with 9.8 acceleration due to gravity, then you will get the 1 kgf. So do you know what is the relation between units of force, that what 1 kgf equals to 10 Newton? So here the acceleration due to gravity, that is g equals to taken as 10, because 9.8 is not easy to in class 8, that's why we are taken as 10. Therefore you can easily define 1 Newton is just, try it, you can try it, just 1 kgf equals to 10 Newton, then what will be 1 Newton? You can give in the comment section the answer. Then comes to our interaction of forces. So have you ever seen an arm wrestling match? So in this case you can see that two persons connect with each other with their hand and applying the force on there. So here after contact they will apply the force. So if both apply the same amount of force, they will be in middle position. If someone has greater force, then one will win, another will lose the game. So here in case of arm wrestling, the interacting bodies are arms of the players. So whenever pushing or pulling a table, that case the interacting bodies are you and the table. So the interaction between you and the table is interacting. That's why we can experience the force. So these are the examples of contact force, because after contact each other we can experience the force. A moving vehicle, the contact the interacting bodies are vehicle and the road or the ground. We can say bat hitting a ball. In this case, interacting bodies are bat and ball. So these are the interaction of forces. Then comes to our balanced or unbalanced, balanced and unbalanced force in a body. So take example, that is the spring is present upon a table and one end is M, another end is N. So if we apply force only in the M side, then the spring will move towards M, and if we apply force towards N, then it will move towards N. But if we apply equal amount of force at the M side and the N side, then what will happen? The spring will not move, right? Because the equal and opposite forces, we are moving to this side and we are moving M into this side, but we are applying same amount of force, then it will be balanced, it will be not move, right? Because what will happen if two equal force applied in the two ends of the spring, if one will apply, then it moves the single end, but if we apply same amount of force on the two ends, then it will not move, because it will balance, the force are balanced each other and it will be in rest. So ever you experience that whenever you kick a football, so after some time it will get into a rest, and after if you off the car it will go down, and after some time it will be in rest position because of the frictional force. So whenever an object is rolling over a surface, the surface provide a opposite force, that is known as frictional force, that's why it will rest. So the ground provide the frictional force. So this also example of contact force, and this is the frictional force try to balance the applied force, that it will comes to in rest position. An unbalanced force can stop a moving objects also. So an object moves with a uniform velocity when no net external force is acting on it, the force acting is balanced on it are balanced. So if not external force, no external force, if a body is in rest position, and if no force is applied upon it, so the force applied by the body and the opposite reaction, it cancel out each other and it will be in balanced condition. So in motion condition also, their force will be in balanced condition, like if a body is moving with a uniform velocity, at that case also the force is balanced also. But in unbalanced force the car will be stopped. Here is a table, two forces applying, like the person is giving F1 force towards this direction, and table who resists to its original position gives a force of F2. So if F1 is the magnitude of the applied force and F2 is the frictional force caused by the rough surface in contact, so the surface contact of the ground to the table will F2 frictional force. If two forces are equal, then the object will be in rest position. If F1 is greater than F2, then this will move towards this direction. Okay, so the net force on the table will be F1 minus F2, then the next force of the table will be F2 minus F1. If the body when the table is moving, that is F1 minus F2 the net force, and the net, if the table is not moving, the net force will be F2 minus F1. So you have to identify that. Sometimes you put a negative negative sign due to represent the direction of the force also. So if you want to get the net force, then you have to multiply, you have to subtract the greater force with the lesser force. So there will be now effect of forces. So what are the effects of forces? So force cannot be seen, heard or tested, only its effects can be felt or seen. It is correctly defined as a push or pull on an object resulting from object's interaction with another object. The various effects of force are: first thing, it can move a body initially at rest. So whenever there is a ball is in rest, so you applied force upon it and kick it, so it will be get into motion. And then next, it can bring a moving body to rest also. So you are riding a bicycle and you applied brake, so initially the cycle is in motion. When you applied the force, so it will get back into its rest position. You can change the direction of moving body also. So when you are playing cricket, so after hitting the ball with the bat, you can change the direction of the ball also, moving ball also. It can change the speed of moving body also. When you applied more force on the cycle's pedal, so the speed of the cycle will change. It can change the shape of the body also. In case of making roti, you can see that after applying force, you can change the shape of the dough. It can change the size of the body also. Let us say example of football, like in the field, when players hit the ball, it starts moving. It starts moving only with applied force. Then a goalkeeper kept the ball. This becomes in rest position. So we can change the direction. Here we can change the size also. Force can be change the size of the object. Force can change the shape of object. Force can deflate a balloon. So when we apply force upon it, and it can change the size and shape also. Then comes to our moment of force. It is a very important thing. Moment of force is also known as torque, and in case it is the, you can simply explain that the rotational effect produced by the force is known as moment of force or torque. So here is one side is fixed and we are applying force in the another end, so it will create a rotational motion. You can take an example of your door also. When you open the door, one side is fixed, but when you apply the force, it will rotate. So that is the moment of force or torque. So it depends upon the applied force and the distance between the point, fixed point, and the applied force position. So it is simply given with the formula, that is your torque equals to force into perpendicular distance. Here the perpendicular distance is this distance is your perpendicular distance. So greater the applied force, the moment will be easy, or greater the distance. If the distance is more, then it can rotate very easily, or you can apply very much amount of force, then also it can rotate. So it is directly proportional to them. If the distance is less and force is less, then the rotation will also less. So this point is known as axis of rotation. Here we applied the force. In the anti-clockwise torque, the axis of rotation will change and the direction of force also will change. Then comes to the unit of torque. So torque is the formula, that is force into perpendicular distance. So the unit of force is Newton, and unit of distance is meter. So unit of torque will be Newton meter. Then comes to your couple. Couple is the double of moment of force or torque, you can say that. Here the axis of rotation will be in center position, and the force applied will be in both the direction with the same amount. So you can see that here it will rotate both in a circular path. So its formula will be double, as like you can moment of force, because in this side also a moment of force and in this side also a moment of force. You can simply write that force into total distance, so you can get the total couple. Then it will be same. Then thrust and press in depth. So there is example. Suppose we have a pile of 3 books on the table. We try to push the pile with the table fingers on the hand. We will be able to move the books easily. However, this will be not in case of try to push pile while index finger. So if there is example, if you go to the depth, some cases you have to easy with pull, or some cases it is easy with push. So if the force per unit area is called pressure, so the force applied by these 3 books on this particular area, that is known as its pressure, that the force per unit area is called pressure, and it will given by the formula pressure equals to force applied by contact area. The pressure is not exerted on this place, only the pressure is exerted in this place, because the force upon the particular area, that is known as the pressure, that is force applied also is called with thrust, because it is the perpendicular force in the downside and the surface contact area, that will be a pressure. And you can write the unit of pressure, that is the unit of force is Newton, and the surface area will be meter square, so the unit of pressure will be Newton per meter square, or it is given by Pascal. So next come to some examples. A force acting on an area of 0.5 meter square produces a pressure of 500 Pascal. Find the value of the force. So we have given surface area and we have given also the pressure, but we have to identify what is the force. So you know that the formula pressure equals to force by area, that is we need the force, so we can get the force by multiply pressure with area. So 0.5 Newton per meter square multiply 500 meter square, so the answer will be 250 Newton, because the unit of force will be in Newton. There is another example also. A force of 100 Newton is applied on area of 2 meter square. What is the pressure resulting from this force? So the pressure will be force by area, so here the force is 100 Newton and area is 2, so we can divide them and we get the answer 50 Newton meters. So there is another question also. A block of wood has a mass of 20 kg and its length, breadth and weight are 30 cm, 25 cm and 10 cm respectively. In which side should be the rest so that it exerts at least pressure of ground? Also calculates pressure. So we have to solve this. So we need the pressure. Pressure equals to force by area. Mass of the wooden block is block into G, that is mass of the wooden block is 20 and G equals to 10. So we get the force, that is 20 Newton. Area equals to 30 by 100 into 25 by 100, that is 0.075 meter square. So the pressure will be 200 by force by area, that is 0.075, that is 2666.7 Newton meter square. So we have asked that which side the pressure will be more, so we have to take the greater side, that is 30 centimeter and 25 centimeter. That's why we multiply 30 centimeter 25 centimeter, so we get the area. The next example, explain why wheels of army tanks are covered over a wide steel belt. The steel belt covering the wheels of army tank has large surface area. This reduces the pressure exerted on the tanks on the ground. As a result, the tank can move easily without damaging the ground or sinking it. So greater the area, surface area, greater will be the less will be the force pressure. So that's why the army tanks have lesser force. And in case if you need less pressure, you can increase the surface area. You know our scientist, that is Blaise Pascal, who introduced the pressure. And have you ever wondered why walking on a sand bed is more difficult than walking on a hard road? Let us understand. Because in case of this, the surface area will less. You already know that to push and ground with some force while walking on this ground. Apply the same amount of force and feel the correct soil particles. Comprising a hard road are tightly bound and immovable. As a result, the reaction force of the ground of our feet is almost equal to the force of our feet on the ground. That's why you can walk easily on the hard road. But a sand bed, on the other hand, consists of loose and movable particles on the sand. While walking, these particles get displaced by force applied by our feet. Consequently, a reaction force of the ground of feet reduces, which makes walking difficult. So if the applied force and the reaction force will be equal, then will be moving easy. And if not, in case of sand like this, we have to face some difficulties to walk. Application of pressures. A few application of pressures are discussed here. If you observe a knife used a cutting vegetables, you will notice that the end of the knife is made very sharp. That's why edge is very small. Therefore, the pressure on the edge is high, which allows to cut the materials very easily with a little effort. But if there will be no sharp area, the surface area will increase, and you have to feel difficulties to cut down. The area over which the weight of a share is distributed is greatly increased by the 6. This reduces the pressure on the snow and thus allow the skier to move over snow without sinking into it. So these are the examples. Then comes to pressure exerted by fluids also. Fluids also exerted pressures. So whenever you put fluid in any container, it exerts equal pressure at the surfaces. If you go down, the pressure will increase. If you put any water in or any liquid in the container, in the bottom position it will be experiencing greater force. If you increasing slightly in the upper side, then for pressure will be decreased slightly. So in case of same here, in every case there is a large pressure in the depth. That's why we use swimming suit when we go in depth inside the sea, because the pressure is very high. Sometimes it can burst your blood vessels also. By using instruments you can also measure the pressure. So that is Borden pressure gauge, manometer and barometer. Using these devices you can measure the pressures. Liquids exerts pressures, so you can take example of a cup and or any bottle you filled with water, and you can make 4 holes vertically. You will observe in the bottom hole the water will move with very much pressure, then the pressure will decrease, then the pressure will decrease, then the pressure will decrease. So whatever I said in the previous, that is the force in the depth is, or sorry, pressure in the depth is very much as compared to the upper position. What happens when you make holes at the same height? If you make a hole on this location and this location, so then the pressure will be exerted equal and the water will be released at the same speed and same pressure. So these are the bullet points. Fluids exert pressure on the walls of the container. Pressure exerted by fluids increase with the depth. Fluids exerts equal pressure at the same depth. You can see that. Then next, consequences of liquid pressures. There is the next topic, that is atmospheric pressure. So you don't feel atmospheric pressure without experience them. Like when you create a vacuum you can experience the atmospheric pressure, there will be atmospheric pressure, but we live in the natural conditions so we would not observe them. But when you create any vacuum you can observe that atmospheric pressure. And the earth is surrounded by envelope of different gases. This envelope is known as simply atmosphere, and the pressure exerted by these gases, that is known as atmospheric pressure. The weight of air is in column height of the atmosphere area, that is 10 cm to 10 cm, is large as 1000 kg. So take an empty soft drink pump, pull it air out in it, and practically there is no left inside the can. This can be done using a vacuum pump. Due to this absence of the air inside the can, it gets squeezed and come under the effect of atmospheric pressure affecting on the outer surface of the can. This is the example. So if you create any vacuum and to vacuum of two walls and the space between them is uh, blank, so there is no atmospheric pressure inside it, you cannot separate them using hots also, because the atmospheric pressure is very large. Measure of atmospheric pressure. So in this way you can measure the atmospheric pressure. So barometer is used for the measurement of pressures also. So barometer construction is there. A hard glass tube is taken and filled with mercury. The open and the tube is closed with a finger. Tube is inverted, cover a trot filled with mercury. The finger is removed only when open and tube is completely immersed in mercury of the trot. On removing the finger, some mercury from the tube flows into the trot. The mercury coulombs shows the height of 76 cm, and mercury is used in barometer because it is the heaviest liquid, hence only 76 meter of the mercury column is needed. In this way you can construct a barometer in your home also. Effects of atmospheric pressure. So whatever I have given the example, these are the effects of atmospheric pressure. So this is the complete detail of this chapter. So if you fill it out in any topic, on this chapter, please ask in the comment section. And I hope you understand this chapter. In the next video we are going to discuss about all the question answer of this chapter in detail, so feel free to ask any questions. Thank you very much guys for watching. If you enjoyed and learned from the video, please like, share and subscribe, and keep watching Apna Guruji. Thank you guys.